Hello everyone, let's begin new chapter, hydrocarbons. So already you have learned some basic concepts of organic chemistry. So here also we will learn organic chemistry little more deeper level. Okay. So first of all, as the chapter name indicates, what is hydrocarbon? So from the term itself we can understand they are compounds which contains hydrogen and carbon. So hydrocarbons are the compounds which contains hydrogen and carbon. And mainly this hydrocarbon is divided into two sections, saturated and unsaturated hydrocarbons. Saturated hydrocarbon. So saturated hydrocarbon means the hydrocarbon where carbon hydrogen is connected with a single bond is known as what? Saturated hydrocarbon. Sorry, a carbon and carbon which is connected with a single bond which is known as saturated hydrocarbons. And unsaturated hydrocarbon means if two carbon atoms were connected by either a double bond or with a triple bond is known as what? Unsaturated hydrocarbon. So the carbon-carbon single bond is present in a hydrocarbon. They are said to be saturated. And if it contains either a double bond or a triple bond, they are known as what? Unsaturated hydrocarbon. Okay. So simply we can say saturated hydrocarbon. The example for saturated hydrocarbon is alkanes. So alkanes are saturated hydrocarbons, and then alkenes and alkynes which contains double bond and triple bond. So they are examples for unsaturated hydrocarbon. So please understand, hydrocarbons are carbon-hydrogen compounds. They are of two types, saturated and unsaturated, on the basis of carbon-carbon, single bond, double bond and triple bond. Okay. So now let's move to the first type of saturated hydrocarbon, that is alkanes. So alkanes is a hydrocarbon which contains carbon-carbon single bond. That's why they are known as what? Saturated hydrocarbon. So let's see alkanes. So alkanes, which is represented with the general formula CnH2n plus 2. The general formula of alkanes is CnH2n plus 2, where this N represents the number of carbon. N represents number of carbon. Okay. So by giving to the N value 1, 2, 3, etc., we will get different types of alkanes. So here only one carbon atom is present. Therefore, first one is known as what? Methane. And coming to the second one, 2 carbon is present, C2H6. So this is ethane. So third one, 3 carbon is present. Therefore, this is propane, and this is butane. Okay. So methane, ethane, propane and butane, these are different members in the alkane family. And here you can see the difference between the two consecutive alkane members. What it differs between CH4 and C2H6, both are differs by a CH2 group. To CH4, if we'll add one more CH2, then we will get C2H6. And to C2H6 again, if we'll add one more CH2, then we will get C3H8. To C3H8 again, if we'll add one more CH2, we will get C4H10. That means all these consecutive members of alkane family is differs by a CH2 group. That is a common factor, and such type of series is known as what? Homologous series. Such type of series is known as homologous series. The series which differs by a common group, that is known as what? Homologous series. So this is the introduction related to this saturated hydrocarbon alkanes. So next is isomerism in alkanes. Next topic is isomerism. Maybe you have already learned the term isomerism. So what is isomer? The compound which exhibit same molecular formula but different structural arrangement is known as what? Isomers, and that phenomenon is known as isomerism. Compounds which exhibit same molecular formula but different structural arrangement. So let's see isomerism in alkanes. So the first example we can see it is butane. So butane, let's consider the example butane. So butane exhibit mainly two type of isomer. Two isomers are exhibited by butane. One is normal butane and second one is isobutane. Normal butane and then second is isobutane. So we know the molecular formula of butane is C4H10. C4H10 is the molecular formula of butane. So on that basis, let's draw the structure of N-butane and isobutane. So normal butane, we know the structure is CH3, then CH2, CH2, CH3. Let's count the number of hydrogen and carbon. Since here 4 carbon, C4, then 3 plus 2, 5, 5 plus 5, here 10. So C4H10 is the molecular formula. But this is the structure of normal butane. Now let's see what is the structure of isobutane. Okay, so we can draw the structure of isobutane as CH3, then CH3, then CH3. Okay, so this is the structure of isobutane where one of the carbon is substituted from the second carbon. That means it's not a straight chain, it's a branched chain. So this is called isobutane. Okay, this is called isobutane, and the correct IUPAC name of this compound is 1, 2, 3. To the second position, if one CH3 group is attached, that's why this is called what? 2-methyl. This compound is known as 2-methyl propane. So remember the two names of this compound. Either this is called isobutane, that is the common name, and the correct IUPAC name of the compound is 2-methyl propane. Okay, but whatever, just count the number of carbon and hydrogen here. Okay, so here total 4 carbon atoms are present and hydrogen 3, 3, 3, 9 plus 1, 10. So whatever its structure is different, but both exhibit same molecular formula, C4H10. Okay, C4H10. So we can call these two, normal butane and isobutane, are the isomers of butane. Clear? So isomers means same molecular formula but different structural arrangement. Now let's see the isomers of pentane. Pentane exhibit 3 isomers, normal pentane, isopentane and neopentane. And note down the IUPAC name of this compound, normal pentane, then normal pentane, its IUPAC name is same, pentane or N-pentane, whatever we can write. Then isopentane, its IUPAC name is 2-methyl butane, and for neopentane it is 2,2-dimethyl propane. 2,2-dimethyl propane. So let's draw the structure of N-pentane, isopentane and neopentane. So this N-pentane is normally CH3, 5 carbon atom, CH3, CH2, CH2, then CH2, CH3, and this is N-pentane. Okay, this is N-pentane. Let's count the number of carbon, 1, 2, 3, 4 and 5, and hydrogen, 3 plus 2, 5, 7, 9 plus 3, it is 12, that is C5H12. C5H12 is the molecular formula, and this is the structure of first isomer, N-pentane. Let's draw the structure of second one, isopentane or 2-methyl butane. So isopentane can be drawn as CH3, CH, CH3, then CH2, CH3. This is isopentane or 2-methyl butane. Why it is called 2-methyl butane means 1, 2, 3 and 4. To the second carbon, the CH3 group is attached. That's why this is called 2-methyl butane. 2-methyl butane, or the common name of this compound is isopentane. Common name of this compound is isopentane. Now the last one is neopentane. What is the structure of neopentane? Let's draw the structure of neopentane as CH3, then C, CH3, CH3, CH3. This is the structure of neopentane. This is neopentane. And let's see the IUPAC name, 2,2-dimethyl propane. And how this name comes means 1, 2, 3. The longest straight chain can be named like this, 1, 2 and 3. To the second carbon, 2-methyl group is attached. That's why it is named as 2,2-dimethyl propane, because straight chain contains only 3 carbon. That's why the name is 2,2-dimethyl propane. So in these 3 cases, cases. This is 1 and this is structure 2 and this is structure 3 of pentane. In these 3 cases we can see one thing, that the molecular formula is same but its structure is totally different. So that's why they are known as isomers. So understand, compounds exhibit same molecular formula but different structure is known as what? Isomers. And remember the isomers, names of isomers of butane and pentane. Butane, normal butane and isobutane, and for pentane, normal pentane, isopentane and neopentane. And remember the IUPAC names of iso and neo compounds. So this is the isomers of pentane, and we can find how many primary, secondary and tertiary carbon atoms are present in this 3 compounds. Okay, before that we should know what is primary carbon and what is secondary carbon and what is tertiary and quaternary carbon atom. So primary carbon, if one carbon atom in a compound is attached to only one carbon attached to only other or single carbon atoms, that is called primary carbon. If one carbon attached to 2 other carbon atoms, that is secondary. To the 3 it is connected, tertiary, and to 4 it is connected, means which is quaternary carbon. So here let's consider this first carbon atom. This first carbon atom connected only to this carbon. So this is primary carbon. But here we can see the second carbon which is connected to 2 other carbon atoms. Therefore this is secondary carbon. The same way this carbon also connected to 2 other carbon. Therefore this is also secondary. So the 2 terminal carbon atoms are primary and the remaining carbon atoms are secondary. Okay. And coming to the second compound, here we can see this carbon attached to only one carbon. So this is primary, and this CH3 also connected with this CH3 only. So this is primary. But this carbon connected to 3 other carbon, 1, 2 and 3. Therefore this is tertiary carbon. And this is connected to 2 other carbon. Therefore this is secondary and this is primary. Coming to this compound, the central carbon is connected to 4 other carbon atoms. Therefore this is what? Quaternary carbon atom. That means after getting a compound you have to identify how many primary, secondary and tertiary carbon atoms are present in the given compound. Primary carbon will connected only to a single carbon. Secondary will connected to 2 other carbon. Tertiary to 3, and quaternary carbon will connect to the 4 other carbon atoms. So let's move to the preparation of alkanes. Okay. So alkanes can be prepared mainly by 4 methods, and the first method, it can be prepared from unsaturated compounds. So unsaturated compounds means already we have discussed, compounds contain either double bond or triple bond. So from the unsaturated compounds, addition of hydrogen in presence of nickel, palladium and platinum, which produce saturated hydrocarbons, that is alkanes. Okay. So alkanes can be prepared from unsaturated compound by the addition of dihydrogen in presence of nickel, palladium and platinum. So since hydrogen is added in presence of these catalysts, the reaction is also known as hydrogenation. The reaction is known as what? Hydrogenation. So here let's see the examples. This is CH2 double bond CH2, that is ethene. The compound is ethene. So to ethene we will add dihydrogen. So when dihydrogen is added to this compound, the H2 bond will break down and we will get 2 hydrogen atom, where one of the hydrogen is given to this carbon and other hydrogen given to the second carbon. Since hydrogen coming to this ethene, the double bond will break down and we will get CH3. CH2 double bond CH2 will break down, and to satisfy the valency, there the 2 hydrogen is attached and finally we will get CH3. This is what? This is ethane. So unsaturated compounds on hydrogenation or by addition of dihydrogen in presence of nickel, palladium, platinum, we will get corresponding saturated compound. That means ethene on hydrogenation we will get ethane. We won't get propane in this case. Same number of carbon atom, that is maintained. Okay. Now let's consider propene. This compound is what? Propene, because it contains 3 carbon with double bond. This is propene. So propene on hydrogenation, what happened here? So the change which happens to the carbon which involves the double bond. So this double bond will break down, and to each carbon the 2 hydrogen is coming, and here CH will turns to CH2, and this CH2 will get one more hydrogen and which turns to CH3. So propene on hydrogenation, we will get propane. Okay. Now third one, unsaturated compounds. Here that we have taken is propine. The unsaturated compounds that we have taken is propine, which contains a triple bond. So first of all, in case of alkynes, double hydrogenation is needed. We have to do the hydrogenation 2 types. Then only we will get the saturated compound. Okay. So here first, to this triple bonded compound, to this alkyne, when hydrogen is added, one of the hydrogen coming to this carbon, because these 2 carbon involves the triple bond, and other hydrogen coming to this carbon. So C turns to CH, and this CH will turns to CH2. Hence one H2 coming, therefore triple bond is breakdown and it turns to a double bond. So first we will get propene. And again, this propene on hydrogenation in presence of nickel, palladium and platinum. Again, hydrogen is attached to this carbon and to this carbon. So it turns to CH2, and this terminal carbon will convert it to CH3, and finally we will get propane. Okay, so hope you understand. If we'll take an alkyne, triple bonded compound means we have to do the hydrogenation 2 times, or directly here we can see, we can give 2H2, then directly we can write down the products. Otherwise, in this manner, step by step, we can do the hydrogenation. So the first method of preparation of alkane is from unsaturated compounds like alkene or alkyne, which is on hydrogenation in presence of nickel, palladium, platinum, produces corresponding alkane. Second method of preparation of alkane is from alkyl halide. So what is alkyl halide? General formula of alkyl halide is Rx. That means one of the hydrogen from the alkane is removed and substituted with a halogen, that is called alkyl halide. Okay. R group represent the alkyl group. To the alkyl group, if any halogen is coming, that is called alkyl halide. So this alkyl halide on reaction with the metal zinc in presence of dilute HCl. Alkyl halide on reaction with metallic zinc in presence of dilute HCl, which gives corresponding alkanes. Okay. By addition of dihydrogen to the alkyl halide, we have to add dihydrogen in presence of zinc and dilute HCl. Then we will get corresponding alkane. And here all alkyl halide except fluorine. So alkyl fluorine do not react with hydrogen in presence of the zinc and dilute HCl. So except fluorine, all other alkyl halides will give this reaction. So here we have taken CH3Cl. This is an alkyl halide. This is chloromethane. This is chloromethane or methyl chloride, we can say. So this methyl chloride on addition of dihydrogen. Addition of dihydrogen in presence of zinc and HCl. So here we have just represent H plus from this HCl, and we will get corresponding. That means I already told you, corresponding alkanes will be obtained. That means in the reactant side, if the alkyl halide contains 1 carbon, the alkanes with 1 carbon will be obtained in the product side also. Corresponding alkanes will be obtained. We cannot obtain a carbon with less number or carbon with higher number, that the alkyl halide from the alkyl halide that we have taken. So note down, here we have taken chloromethane. So here, when it combines with hydrogen, this chlorine will combines with one of the hydrogen, and other hydrogen will attach to the CH3, and CH3 accepts one hydrogen and turns to CH4, and the remaining hydrogen will combines with this chlorine and turns to HCl. So here chloromethane, remember the name of compound, this is chloromethane, addition of dihydrogen in presence of zinc and HCl, we will get methane. What is the compound? It is methane we will get. Second one is ethyl chloride, C2H5Cl. This is ethyl chloride, an alkyl halide, combines with dihydrogen in presence of zinc and HCl. Corresponding alkane will be obtained. Ethyl chloride on addition of dihydrogen in presence of zinc and HCl, it turns to C2H6. This is what? 2 carbon, therefore this is ethane. And CH3, CH2, CH2Cl. This is what? Propyl chloride. This is propyl chloride, or we can say chloropropane. Okay, so propyl chloride on addition of dihydrogen in presence of zinc and HCl, we will get propane along with HCl. So from the alkyl halide, we can prepare alkanes in 2 ways. From alkyl halide in 2 ways we can prepare alkane. First method, directly treat alkyl halide with dihydrogen in presence of zinc and dilute HCl. Second way to prepare alkanes from alkyl halide is the name reaction. Just note down, this is called Woods reaction. The reaction is Woods reaction. So in this Woods reaction, what we will do means, alkyl halide, 2 molecules of alkyl halide, 2 molecules of alkyl halide should be treated with metallic sodium. 2 molecules of alkyl halide should be treated with metallic sodium. In presence of dry ether, we will get alkane. Okay, so this is Woods reaction. So what is Woods reaction? One of the method used for the preparation of alkane from where? From alkyl halide. So alkyl halide on treating with metallic sodium in presence of dry ether, we will get alkane. So let's see this with the help of examples. So here the basic alkyl halide, chloromethane or methyl chloride is taken. 2 molecules of methyl chloride is taken, should be treated with 2Na. Okay, treated with metallic sodium in presence of dry ether. In presence of dry ether, then these 2 CH3 group will combine. 2 CH3 groups will combine and we will get ethane. What we will get? Here we will get ethane, and this sodium will combine with these 2 bromine molecule liberated and turns to 2NaBr. Okay. So this is the first method of preparation of alkanes by Woods reaction. Alkyl halide should be treated with metallic sodium in presence of dry ether. Second one is C2H5Br. C2H5Br on treating with metallic sodium, then 2 molecules of C2H5Br on treating with metallic sodium in presence of dry ether, C2H5, and these C2H5 will connected, and what is this compound? Total 4 carbon, so C4H10, this is what? This is butane. So what is the drawback of this Woods reaction? What is the limitation of this Woods reaction? Means using Woods reaction we can prepare only symmetrical alkenes, or the alkenes which contains even number of carbon atom. The limitation of Woods reaction, using Woods reaction we can prepare the alkanes contains even number of carbon atom. Alkanes with odd number of carbon atom cannot be prepared by using this Woods reaction. Okay, that is the limitation of Woods reaction. That is very important. Please note down. So that's why first methane cannot be prepared by this method, because methane which contains only 1 carbon. So we can't prepare methane by using the Woods reaction. So ethane, butane, then hexane, etc. Like the alkanes which contain even number of carbon atoms only can be prepared by this Woods reaction, because we are taking here 2 molecules of alkyl halide, and that alkyl groups will be combined, and finally we will get an alkane with even number of carbon atom. Anyhow, remember the preparation of alkanes from alkyl halide can be carried out in 2 ways. One is direct treatment with dihydrogen in presence of zinc and dilute HCl. Second is by Woods reaction. Third method of preparation of alkanes is from carboxylic acid. We know what is carboxylic acid. The functional group is RCOOH. This is what? Carboxylic acid. R can be any of the alkyl group. So RCOOH is the functional group of carboxylic acid. So from the, we cannot prepare the alkanes directly from the carboxylic acid. We can prepare it from the sodium salt of carboxylic acid. Okay. So how the sodium salt of carboxylic acid is obtained means, this hydrogen, terminal hydrogen can be removed and substituted with sodium. We will get sodium salt of carboxylic acid, that is RCOONA. So this RCOONA, which is known as what? Sodium salt of carboxylic acid. From any of the carboxylic acid, remove the terminal hydrogen and should be added with sodium. We will get sodium salt of carboxylic acid. So here, sodium salt of carboxylic acid on heated in presence of soda lime. So soda lime is a chemical which is the combination of sodium hydroxide plus calcium oxide. So the combination of sodium hydroxide plus calcium oxide, that is called the chemical soda lime. So sodium salt of carboxylic acid, that is this RCOONA, on heating with soda lime, we will get corresponding alkanes. Okay, alkanes will be obtained by this process. But here, what is the speciality means? We will get the alkanes with one carbon atom less than the carboxylic acid. We will get the alkanes which contains one carbon atom less than the carboxylic acid. That means if we'll taken the carboxylic acid contains two carbon atoms, then the alkane will be obtained contains only one carbon atom. For example, we can take the alkane, we can take the carboxylic acid CH3COOH. So this is acetic acid, or we can call ethanoic acid, acetic acid or ethanoic acid. So we have to take the sodium salt of this carboxylic acid. That's why the terminal hydrogen can be substituted with what? Sodium. So now this compound is known as sodium salt of acetic acid, or this is called sodium acetate. The compound is called what? Sodium acetate. And it should be heated with what? Soda lime. Should be heated with soda lime. So soda lime we have already told, this is NaOH and calcium oxide, and should be heated strongly. And on heating, here what happens means that the carbon dioxide from this compound, from this sodium salt of carboxylic acid, COO is removed. COO is removed on heating. Therefore, since carbon dioxide is removed from this process, this is also known as decarboxylation. The reaction is also known as what? Decarboxylation, due to the removal of carbon dioxide. And what is the desired product we need? We need the product as alkane. But what is the speciality of this reaction? We will get alkanes with one carbon atom less than the carboxylic acid that we are taken. So here CH3COONA, which contains total 2 carbon atoms. So 2 minus 1, we will get 1. So the alkanes which contains single carbon we will get, that is methane, will be obtained by heating the sodium acetate with soda lime. And the eliminated carbon dioxide will combines with the combines with this sodium, and which forms Na2CO3. Okay. So in this manner we can prepare alkanes from carboxylic acid, especially from the sodium salt of carboxylic acid. Should be heated with soda lime. We will get alkanes with one carbon atom less than the carboxylic acid that we have taken. Okay. So suppose if we need to prepare butane means, we have to take the carboxylic acid which contains how many carbon? 5 carbon. Or if we need to prepare pentane means carboxylic acid which contains 6 carbon should be taken. So whatever may be the corresponding alkanes we need to prepare, accordingly we have to select the carboxylic acid which contains 1 carbon higher than the product we expected. Okay. So please understand this relation. This is very important aspect of this reaction. Now We can prepare alkanes from carboxylic acid in one more way, that is a name reaction, Kolb's electrolytic method. Second method to prepare alkanes from carboxylic acid is Kolb's electrolytic method. So electrolytic method, as the name indicate, it's an electrolysis process. Okay, and here what happens means aqueous solution of sodium or potassium salt of, here we can take either sodium or potassium salt of carboxylic acid. That means in this case also we are not taking carboxylic acid directly. It's sodium or potassium salt will be taken. So this sodium or potassium salt of carboxylic acid, which is on electrolysis, we will get alkanes. Which is on electrolysis, we will get alkanes. And here the speciality, using this Kolb's electrolytic method, like Wood's reaction, the alkanes which contains only even number of carbon can be prepared by this method. That is the drawback of this Kolb's method. So please connect both reaction. Kolb's method also we can prepare alkanes, but only alkanes contains even number of carbon atoms, like ethane or butane, hexane, etc. Like even number of carbon atoms, alkanes only can be prepared by this Kolb's electrolytic method. That is the limitation of this method. But here aqueous solution of either sodium or potassium salt can be used. But first method we can use only sodium salt of carboxylic acid. Okay, so let's write down the reaction here. Sodium or potassium salt of carboxylic acid. So we will take CH3COO-Na. Okay, 2 molecules can be taken, and it is said that aqueous solution of sodium or potassium salt of carboxylic acid. So we should add water molecule here, 2H2O, and which is on electrolysis. That is, when current passes through this, we will get the carboxylic acid taken as CH3COO-Na. So 2 molecules are taken. Therefore, the corresponding alkane will be CH3CH3. And this on electrolysis, carbon dioxide gets removed from the compound. So we will get one byproduct carbon dioxide, and this sodium will combine with the water, and which forms NaOH. Okay. So this is example for Kolb's electrolytic method, and from the Kolb's electrolytic method we can prepare alkanes which contains even number of carbon atom. Only alkanes contains even number of carbon atom can be prepared, even though the reactants in both cases are same. Okay. So please note down the 3 important methods that we have discussed for the preparation of alkanes. And this is first time we are dealing long reactions of organic chemistry. So definitely you will feel difficulties in the beginning, but repeat or revise the content again, and then make sure that you are thorough with this preparation methods. Okay. So thank you all.